So in this video here, we're going to find the Laurent series in a punctured disk centered around z equals 3, obviously where z is a complex number as we're into Laurent series, for 1 over z minus 3 and z minus 5. So a couple of ways we could go about this, but the way I would start here is to do a change of variable and let w equal z minus 3. So let's do that first. And then do our substitution into here. So we'll let f of z equal this first of all. So f of z equals 1 over z minus 3, z minus 5. So now let's do a change of variable for f of w. So f of w will now become 1 over z minus 3, that's my w, and z minus 5, that's going to be w minus 2. So just put that in brackets next to it. Okay, now what we're going to do here, well, as we're trying to get a Laurent series, we want to get some sort of power series representation of this by manipulation of the algebra. So what I'm going to do now is do partial fraction composition of this. So 1 over w minus 2, that's going to be of the form of a over w plus b over w minus 2. Okay, now what we can do there, just do the cover up method, and that will work really well here. So if I plug in w equals 0 in here, I can find the a. So if I put that one there, we'll cover up, plug in 0, I've got minus a half. So a equals minus 1/2. If you're unsure of how the cover up method and partial fraction decomposition works, check the link below. I've got loads of examples for you. And then for b, cover up for this, we want w to equal 2. That's going to go, plug in 2 here, we've got a half. So now our f of w, now that becomes a is minus 1/2, so that's minus 1 over 2w. I can just do it like that. And then plus b over w minus 2. What is b? b is 1/2, so that's plus. So it's plus 1/2 and w minus 2. I must put a bracket there for that one. Okay, so that takes care of that. Now what I want to do is get a power series representation out of this. Now minus a half w, that's pretty much taken care of. But I could do some work on this one. So if I look at 1/2 of w minus 2, let's just look at that on its own. I can factor out the half, and then I've got 1 over w minus 2. So I do a multiply 1 over w minus 2. Now I can do something with a bit of manipulation. Now the most famous power series that helps us out is 1 over 1 minus x, where x is some function of x or z or whatever you want, and then that will give us our very famous power series. So here let's do some manipulation on that. So then that, if I was to factor out minus 1/2, so I'll keep this half here first, so I'm going to put that in a bracket, and I haven't got it here in a bracket, but if I do that I'll keep this multiply. Then do a minus a half in a bracket. So that's factored out minus a half. And then what will happen is the w will become negative, and this 2, although factor out by the 2, will become positive. So then I will have 1 over 1 minus w over 2. Okay, so you can see now if I distribute that back in, I've got minus 2 in my denominator here. And in here, I would have plus w, which is what I've got there. So that's what I want there. So now close off the bracket when I'm happy with that. Now I've got this series representation of this, because this, in series representation, if n goes from 0 to infinity, what I've got here is x to the n. Now here, I've got w over 2. So for this, if I just put this over here, 1 over 1 minus w over 2. That, using that and transferring from this, that then becomes power series from n equals 0 to infinity. All I need to do now is put the w over 2 to the power of n. So that's what I've got there. Okay, so now what I'm going to do is I'm going to rewrite this with these bits added into this. So minus 1/2 and then w. So I've got my w there. And then w. So that takes care of that. Then this one, I've got my 1/2 minus 1/2, so that becomes minus 1/4. So then add that on, minus 1/4, put that in brackets, and then here I've just got this. So I've now got the sum n equals 0 to infinity, w over 2 to the n. Okay, right, now let's clear this working off the board, and then let's start to find our Laurent series from what we've got here. Okay, so now we've got our expansion here and with the power series here, so well on the way to making our Laurent series. But we've still got a variable here with w. So we know w equals z minus 3. This was our original question for the punctured disk around z equals 3. So what we've got to do now is go back to our variable of z. So w is z minus 3, so let's plug those in. So now f of z equals minus 1 over 2 z minus 3, and then add minus 1/4 times the summation of w, again z minus 3 over 2. So I've got z minus 3 over 2, and that's the power of n. Okay, now let's work out now where this is valid. So I'm going to do the first 3 terms of this in a moment, from n equals 0 to n equals 2, but you can keep going if you wish. But where is this Laurent series valid? Now we want the punctured disk centered around z equals 3. But if we go out to z minus 5, we notice we've got a singularity. So what we need is the absolute value of z minus 3 to be from 0 to 2. So that's what we want. So if I write here, we've got z minus 3, that's got to be less than 2 and greater than 0. Notice 0 is not included because it's a punctured disk. So actually at z equals 3, this is also not included for that. So punctured disk, this one here would give us a valid expansion for this range of values for absolute value of z minus 3 from 0 to 2. Okay, now let's get the first 3 terms. So if n equals 0, f of z, so let's put a subscript 0 in there. 1 minus 1 over 2, z minus 3, so that's not going to change. So I've got minus 1 over 2 z minus 3. And then if n is 0 here, I've just got a 1. So anything to the power of 0 is always 1. So that's minus 1/4. So that's what I've got at n equals 0. Now let's try when n equals 1. So I'm going to call this f of z subscript 1. So plug in n equals 1. So now I've already got this term here taken care of. I need to worry about that once. So that will stay there with this. Now when n equals 1. So when n equals 1, I've still got minus 1/4. Then n equals 1, I've got z minus 3 over 2 to the power of 1. So z minus 3 over 2. So that's my extra term for my when n is 1. Now when n is 2, let's just call this f z subscript 2. So again, I've already got this term. So now let's plug in n is 2. So I've got minus 1/4. And then when n is 2, I've got z minus 3 squared. This will be squared, so that's over 4. So z minus 3 squared, let's write that on the top, z minus 3 squared over 4. I could have done the same here. Let's change that one back, because I can now change these brackets and get the terms in the same format when I bring them together. So now my Laurent series for this, f of z, let's write out some of the terms. Minus 1 over 2 over z minus 3 and minus a quarter. So I'm going to put the constant first. So minus a quarter. Then I've got minus 1 over 2z, let's change that 2 so it doesn't look like a z, 2z minus 3. Then here, times this all by minus a quarter. So I've got z minus 3. It's going to give me a negative. So I've got z minus 3. So that takes care of that. And then I've got 4 over 2. So that's going to give me 8. And then the next term, I've got minus a quarter z minus 3 squared. So I've now got a minus again. So I've got minus z minus 3 squared. And this time I've got 4 4s, which is 16. And then we can keep going on and on. So I'm just going to put my big O notation in there for O z cubed. And that says from z cubed onwards. And that being my Laurent series representation, punctured disk around z equals 3. So the next video I'm going to show you how to do it if this same term was centered around z equals 5. Okay.